Hi, this is Miss Borgen and
Mrs. Catalano. In this video, we're going to be learning about some of the components attributed to quality experimental design.
make sure you have your notes in your notebook as you complete this lesson. Pause the video as needed to make sure you have all the important information recorded. Questions are usually posed by the teacher, but occasionally you may need to pose your own question, such as, how does fertilizer affect plant growth?
Your hypothesis would be a prediction that ties your independent and dependent variable together. We might hypothesize, for example, that as the amount of fertilizer added to a plant is increased, overall growth rate will also increase.
Once our experiment is complete and our data is assessed, we can then state a claim to answer a question.
The definition for independent variable is a variable whose variation doesn't depend on that of another. It's often described as X.
I like to think of the independent variable as the variable that the experimenter changes. The dependent variable is the variable whose value depends on that of another.
In other words, it's the variable that's being measured.
In our example, what would be the independent variable?
Well, the variable that we're changing is the addition of fertilizer.
And since we are measuring how much the plant will grow, that makes it our dependent variable. A term that we will be using in our experiment is levels. Levels, also known as treatments, show how changing the independent variable will alter the dependent variable.
Each level should produce a different effect on the dependent variable.
We've decided that our independent treatments will be 5, 10, and 15 grams of fertilizer.
These treatments will provide us with different rates of plant growth.
We think. But don't plants grow without fertilizer anyways?
That's right. So to give us a baseline to compare to, we need a control.
A scientific control is a variation of the treatment which allows scientists to compare the experimental outcome to normal results. There are actually different types of controls. Positive controls show what the results will look like in a lab setting.
They show what should happen. If you look, in a Biuret test, even a negative test produces a color change. The only way to recognize a positive response is to see what it should look like by testing it on something that we know will produce a positive result.
A negative control is a group in which no response is expected,
which makes our negative control no fertilizer. Our negative control lets us prove that any increase or decrease in growth is a reflection of the fertilizer, not normal plant behavior.
In other words, it proves that what we changed actually causes the change, but we need to ensure that the fertilizer is the only factor affecting plant growth.
Which is why we need constants. Constants are elements within an experiment that go unchanged throughout the entire exploration.
That includes things like sunlight, the species of plants, and the amount of water used.
But before we can collect our data, we need somewhere to put it. For my experiment, I wanted to see how the fertilizer affects plant growth over a period of time. In my data table, I split up the growth by days so that I can measure the change over time.
I just care about reliable results, so I did multiple trials for each treatment.
Calculating the average for those trials would give you even more accurate data.
What if what we're studying can't be measured, like how happy my plants are from the fertilizer?
Well, I'm not sure how you'd measure the happiness of a plant, but you can still record meaningful data in the form of descriptions. This is called qualitative data.
Well, which kind of data is better?
While quantitative data, like the measurements we collected from our plant's growth, is difficult to dispute, a good experiment will record both.
Oh, like the fact that my plant with 10 grams of fertilizer had a deeper green color.
Precisely. Just because your plant with 15 grams of fertilizer grew taller doesn't mean it was the healthiest plant.
Now that we've collected our data, we can look back at our hypothesis and create a claim to answer our question.
Our hypothesis was created before we knew our results. While you could have a good or bad hypothesis, you can't really have a wrong one. And now that we've collected our data, we can formulate our claim.
That means our claim is 15 grams of fertilizer results in maximum plant growth.
Wow, that was a short and direct sentence that summarized the main point of our experiment. Great job!
If you have any questions that weren't answered in this video, make sure to write them down so we can address them in class.